Okay, students, now what happens if I am subtracting a polynomial? Well, it's very similar to polynomial addition. The only difference is in polynomial addition, you would have a plus sign in between both parentheses. In polynomial subtraction, you have a negative sign in front of your parentheses. However, if you notice that there's a negative sign in front of parentheses, we should recognize that. We've seen this situation a few times before. That's actually distribution. So really what's going to happen is I'm going to distribute this negative into the second set of parentheses. Then after I distribute, then it'll become polynomial addition. Watch. So the first thing I am going to do is I'm not going to change my first polynomial. So 3x to the fifth power plus 4x to the fourth power. Whoops. Plus 4x to the fourth power minus 7x to the third power plus 2x plus 6. That's not going to change. Now, what I am going to do, though, is I'm going to distribute right here. So let's actually set this up as multiplication. So -1 times, let's change that to a dot. That's better. -1 times 3x to the fourth power plus -1 times -5x to the second power and -1 times -4. So, what would happen after that? Well, the first thing that would happen is this would stay exactly the same. My first polynomial is not going to change at all. Now, the only thing that's really going to change here is just the signs. I mean, anything you multiply by 1 isn't going to change. But anything multiplied by -1, now you're going to have some negative signs. So we'll have -3x to the fourth power. Instead of -5x squared, now it'll be positive 5x squared. And instead of -4, now it'll be positive 4. So, and really for just the sake of keeping things similar, I'm going to reform this back as addition now that I've distributed everything. And that way it just kind of keeps me familiar with the I'm adding or subtracting polynomials. So it's -3x to the fourth power plus 5x to the second power plus 4. Now I can go ahead and I can set up my addition. So again, the first chain is going to stay unchanged. So let's just write that out. Now the next chain, let's fill in all the blanks. So let's have a plus sign. I have 0x to the fifth power because in my polynomial I don't have an x to the fifth power. And I want to create a situation where I have a space vertically for every exponent. No, personally, I think that's important. And it's not so much of a math thing as it is just a sight thing. It's just easier for us to recognize because, when you're growing up like in elementary school, you're used to seeing a number. I mean, what happens if you don't see a number? What are you going to do then? Have you correctly trained your brain into actually recognizing that, oh, okay, I don't have an exponent here, so I don't have to do anything? We could do that, or you can just go with something that you're very familiar with, which is putting a 0, because you've practiced, 3 plus 0. You know that's 3. So it's a little bit easier for us to just put a number there. If nothing exists, then we put 0. That's okay. Now I can add everything. So I have 3x to the 5th powers, and I have no more x to the 5th powers, so I have 3x to the 5th powers total. Here I have negative 4x to the 4th powers, and I'm taking away 3, so I have 1 left. Here I have negative 7x to the 3rd powers, and I have nothing else to add or subtract to it. So I have negative x to the 3rd powers total. Here I have 5x to the 2nd power, then I'm not doing anything else with it, so that's positive 5x. I have positive 5x to the 2nd power. Here I have 2x's, I don't have any more. So that's 2x. And 6 plus 4 is 10. If I take a quick look, whoops, made a slight error here. That's x to the 4th power, and then put that in. If I take a quick peek here, I look at all these exponents. No, there's no other matching exponents or variables. So I can't add anything else, so that's as much as I can add. So that's how you complete a polynomial subtraction problem. Distribute first, distribute the negative into my second parentheses, then go ahead and add. So there's really not subtraction at all. It's polynomial distribution, then polynomial addition. Hope this helps.